Science!
All right, D-Man. So on Science this week, I've got two separate stories, but they're basically the same vein. There are a couple spacecraft that ended their missions over the last week.
I mean, it's inevitable, right?
It is inevitable. First up, I want to talk about NASA's Dawn mission. Now, Dawn was sent to observe the two largest bodies in the asteroid belt, Vesta and the dwarf planet Ceres. Dawn launched in 2007 and actually, through all of its time out there, has put over 4.3 billion miles on its odometer.
Whoa!
So it's very hardworking. It orbited Vesta, the one body out there, for more than a year, and it found that a grouping of meteorites, abbreviated HED, actually came from Vesta. We were able to take samples of Vesta and find out that the same chemical compositions were the same stuff that have impacted Earth and the Moon.
Ooh.
So we knew that they came from there, and this large celestial body, it's about the size of Saturn's moon and Enceladus, actually contained hydrated and carbon-rich material. There's a lot of water on this celestial body, which we did not know just looking at it through a telescope. And I think that's pretty cool. The spacecraft Dawn also orbited Ceres and found that the only dwarf planet we have in our inner solar system has an ocean where ammonia and water react with silicate rocks. So that ocean of water and ammonia actually freezes and deposits a lot of this material, and it's exposed. So when it was orbiting this dwarf planet, we were actually able to see all of this material and find out that there was organic material mixed in with the mix as well.
Weird. Remember when water and organic material in space was a thing that we didn't even know existed?
Science fiction.
It's so weird that we're just finding it everywhere now.
Yeah. And not only talking about science fiction, the coolest thing about Dawn is it was propelled by ion propulsion, and that literally came from Star Trek. And now
weird.
exists in reality.
I love it when technology like perfectly reflects science fiction, and it does so many times where, I mean, the idea sparks from these stories that we make up, and then it gives these scientists ideas of what to actually do with the future of technology. It's pretty intense.
It is pretty intense. I have a really cool video about the final mission of Dawn here, right from the European Space Agency, and check that out.
You know, when you work on a mission this long, it feels like a part of you. I've been a space enthusiast since I was 4 years old. Getting to work on a mission like this it's a dream come true. To me, Dawn is truly Earth's first interplanetary spaceship. No other spacecraft has gone to a distant body, gone into orbit around it, maneuvered there, then broken out of orbit, traveled elsewhere in the solar system to another alien world, and gone into orbit around it. And it does that with ion propulsion, which I first heard of in a Star Trek episode. We've turned ion propulsion from science fiction into science fact.
The Dawn mission really is a journey back to the beginning of the solar system, and that's why we call it Dawn. We chose two time capsules from the beginning of the solar system, Vesta and Ceres, which are the most massive and largest bodies in the main asteroid belt. They both formed very early when the solar system was forming out of the protoplanetary disk, and yet they ended up in these two very different states. Vesta is a dry, rocky body that looks a lot like our moon, whereas Ceres had a lot of water, and it looks much more like the icy moons of the outer solar system.
And it seems like what determined their eventual fate was the location where they started. And we now believe that Ceres formed much farther from the sun than it is now.
When Dawn found the bright material on Ceres, what we saw was completely mind-blowing. It was made of sodium carbonate. Sodium carbonate is not common in the solar system, but we see it coming out of the plumes of Enceladus. We see it in lakes on Earth, and here it was on the surface of Ceres.
The mission will end when Dawn runs out of the conventional chemical propellant that it uses to orient itself in the zero gravity of space. Dawn will become this inert celestial monument in orbit around the dwarf planet that it unveiled. Dawn serves as a lasting reminder that the passion for bold adventures and our noble aspirations to reach out into the cosmos take us far, far beyond the confines of our humble home here on planet Earth.
So super cool.
Yeah.
The spacecraft ran out of fuel officially on November 1st, and because Ceres has conditions that interest of science and scientists who study chemistry that could lead to the development of life, NASA follows very strict protocols for planetary protection and disposal of spacecraft like this. So that being said, Dawn will remain in orbit for at least 20 years, but engineers have more than 99% confidence the orbit will last at least 50 years.
Wow.
Dr. Carol Raymond, who is NASA's Jet Propulsion Laboratory investigator, said, in many ways, Dawn's legacy is just beginning. Dawn's data sets will be deeply mined by scientists working on how planets grow and differentiate and when and where life could have formed in our solar system. Ceres and Vesta are important to the study of distant planetary systems, too, as they provide a glimpse of the conditions that may exist around young stars. So we're getting a lot of data about the inception of the solar system, the inception
incredible.
of planets in the universe. It's very, very incredible. So, again, this spacecraft's mission has ended, but we have tons of data to go through for years and years to come. The same can be said about another spacecraft whose mission has ended, and that is NASA's Kepler telescope. We've talked about this a lot on this show, actually, and I have a bless you.
Thank you.
And I have a Kepler by the numbers graphic up here that just gives you a scope of all the things that Kepler did. In 2009, Kepler was launched to reveal that there was, and it worked tirelessly to reveal that there is statistically at least one planet around every star that you can see in the Milky Way.
Wow.
Like, statistically speaking. And that's pretty crazy. Kepler also found over 2,600 different worlds outside of our solar system, including Earth-like planets with the possibility of water in the fabled Goldilocks zone, and also super-Earths, which we've also talked about on this show a couple times.
So it's found potential locations that we could actually...
Insane amount of locations. And in fact, before we put Kepler in orbit, we never really understood the gravity, pun intended, of where planets exist in the universe and how many exist in the universe. And now, thanks to Kepler and other things that we have in place, like TESS and these things that are out there now continuing to work and scan the sky, the amount of planets that are out there, again, it's silly to think that we're alone in the universe.
Yeah.
And again, I have another amazing video from NASA that deals with the Kepler mission and really gives you a scope of what was achieved by this ingenuity of humankind.
A telescope?
For thousands of years, mankind has wondered, are there planets around other stars? Is there life out there? But we didn't know. We didn't know if there were any planets around the stars.
0 and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Before the launch of Kepler, most of the planets we knew about were really big planets like Jupiter. But Kepler was so sensitive that we started finding smaller and smaller planets.
We discovered planets smaller than had ever been discovered before, and just many of them, indicating that the galaxy's full of planets. Crazy worlds that we didn't predict, things that we hadn't imagined. We find planets orbiting so close to their parent star that the star-facing side has temperatures in excess of that required to melt iron. These planets have an entire hemisphere that's like a liquid ocean, but it's not an ocean of water. It's an ocean of molten rock. We see planets that are orbiting not one, but two stars. That is, if you look in the east, you'd see not one star rise, but two.
Almost all the astronomers that I know grew up reading science fiction. That's why a lot of them got into the business of looking for planets in the first place, to find out if any of this, fantastic speculation that inspired us could be true. And now we find out that, yeah, it could be true.
We learned from Kepler that the most common types of planets in the galaxy are unlike the planets in our own solar system. These worlds are intermediate in size between the Earth and Neptune, but we're not exactly sure what they're made out of.
What are the things that we know now that we didn't know then? I mean, things like planets are ubiquitous. Planets are diverse. The stars that we find planets around are diverse. The systems that planets live in vary widely.
It was breathtaking to see all of the planets come rolling in from this exquisite data over the years that we were collecting data with Kepler. In the end, we found dozens of small, potentially rocky worlds orbiting in the Goldilocks zone of their stars, that distance at which you can have liquid water pooling on the surface of the planet, capable of supporting life as we know it.
The science value of the collected data spans almost every field of astronomy and planetary science. It revolutionized not just exoplanets, not just stars, but a large number of the scientific fields of astronomy today.
There's one summer I worked in an observatory, and I would go outside at night and look up at the stars and just be blown away at how vast space was. And it actually felt a little lonely. And when I go out and look at the night sky now, rather than being awestruck by the vastness, I'm awestruck by the possibility.
There aren't that many opportunities in life where you get to participate in a project as important as Kepler is, that answers such a fundamental question that we've been asking ourselves for so long. Now we know when we look up into the night sky that every star we see has on average at least one planet, and that many of those planets are similar in size to the Earth and a chance for life as we know it elsewhere.
Searching for life elsewhere is one of the key themes that drive our science portfolio, and at the center of that is Kepler. New missions, like the Transiting Exoplanet Survey satellite TESS and the James Webb Space Telescope, will build on Kepler's success and take our search for life to new heights.
It has been extremely gratifying to see the data come back from the mission and show what we wanted to know, give us the answer. Many stars have planets. A lot of these planets are Earth-sized. That's Kepler's legacy, this new knowledge that we have about planets around other stars.
Yeah, I mean, we're living in an age, I remember being a kid and, looking up at the sky and being like, I wonder if aliens are real. I wonder if, we're alone in the universe. Not only do we have things like Kepler that have proven that there are countless planets out there, but we have discovered life on other planets. We've discovered microscopic organic material and this kind of thing that are out in the universe. So it's like, it's only a matter of time before we really can hone in on this data and find out that there are planets out there that 100% are supporting, complex life forms.
And I feel like we're just getting started. I mean, you look at Kepler, this thing is technology from 10 years ago.
Yeah.
Can you imagine the amount of technology, knowledge that we've gained from 10 years ago into now, and what things we're shooting out into space now, what kind of information we'll be gathering from that 10 years from now.
Yeah, it's crazy. And like you said, not only was the mission of Kepler put out there, years ago, it prolonged its life. And we talked about this on this show when it became its second part of the mission, K2. Basically, what happened was in 2012, Kepler completed its primary mission. And then 2 of its gyroscopes failed. And because it had done so well, scientists really wanted to continue the spacecraft and continue it trying to find data. So NASA engineers found a way to use solar pressure to keep the spacecraft temporarily pointed in a desired direction, and they did that since 2013.
Wow.
And so that was the beginning of K2, and it still was scanning the sky and still finding more and more and more and more stuff. It has been running ever since, gathering science from 19 different patches of the sky with populations of stars, galaxies, and solar system objects. The mountain of data from Kepler, it will not only be poured over by scientists for many years to come, it is going to affect the entirety of the next generation of science, of astronomy, of space exploration.
Well, it's just a starting point. Now we know where to start looking, and now we can actually dig in and look deeply. We can actually take a closer and more focused look at these planets that we think could possibly be habitable or could harbor life.
Yeah.
It's pretty nuts.
It is pretty nuts. It's pretty cool. It's a cool time to love space and space exploration. That's why we love talking about it on the show when we can, and we like that we're getting a great feedback from you guys, like when we're talking about it too, because it makes us feel good about it. Because, I've been nerding out about this stuff my entire life, and there was a long period of time where nobody cared.
Yeah.
I was saying this the other day, like even 5 years ago, you'd be hard-pressed to go on just a normal street in a city in America and find someone repping NASA. And now, from celebrities to normal people, in everyday life, you see people wearing a NASA shirt or a NASA hat or something like that.
And I think a lot of that is because of podcasting.
I think so, too.
Because guys like Neil deGrasse Tyson or Michio Kaku can be out in the open and have 3-hour-long conversations about these awesome things, and everybody's tuning into like the Joe Rogan podcast to hear every single word that these guys are pouring over. It's amazing. It's an amazing time.
It really is. So, we're going to keep following the stuff, and I just wanted to talk about both of these because even though both these spacecraft, their mission is over, it's not the end of what they were able to achieve. We're going to be dealing with Dawn and Kepler and the data that we got from both of them for years and years to come.